I already have some instances spun up, and then I'm going to show the UI. I have a demo script to write data, and we'll create some failures in the cluster and see how it recovers. And then we'll close out with adding a new server to the cluster and getting it up and running. So with Enterprise, it comes with three separate binaries, right? So you can sign up for Enterprise at portal.influxdata.com, and the three separate binaries are basically the meta binary, the data binary, and the web binary. So meta nodes are basically the consensus group that hold data about the cluster, like what servers exist, what databases exist, what users there are, and what continuous queries are running. They can be installed and set up on servers separate from the data nodes, and generally you can use very modest hardware for it. So T2 smalls or T2 nanos are good enough for meta nodes. And what you want for those is three of those type. Anywhere you would either have 3 or you'd have 5. And the reason you'd have 5 instead of 3 is because with 5 you can tolerate 2 failures and the whole system will still be up and running healthily. So then the other type of node is the data node. Data nodes handle all queries, they handle all writes, and they store the raw time series data and all the metadata about the time series themselves, like the measurements, the tags, that kind of stuff. For data nodes, you want those to be larger hardware, and you can have 2 or more of those. So you don't need to have 3 data nodes to have a cluster that is highly available. So here, I can switch to my script here. I have a bunch of commands that I've created ahead of time so that I don't have to fat finger keys, and I can just copy and paste stuff. So the first thing we want to do is set up the Enterprise web app. Now, it requires Postgres. Now, in a normal installation, you'd have you'd use RDS in Amazon, but in this case, here I have a server for running Enterprise. I have Postgres running on it here. Yeah, you can see we're running 9.4 here. So the first thing we need to do is we need to create the Enterprise database. So you just bring up the Postgres console, create database, Enterprise. Okay, so I've actually already created it, so then we can bail out. And then we want to install the Enterprise binary. So in this case, it's 060. So the command looks like this, right? We're on Ubuntu in this case, so we're using the Debian packages. We also have RPMs and tarballs of the raw binaries as well. So assuming we've done that install, the next thing we want to do is we want to edit our config. Right, so our config is in etc, Influx Enterprise, and enterprise.conf. So things we want to put in are the URL, the host name, and the port that we want to run on, and then the license key. So in this case, I just used the raw IP. Obviously, normally what you'd want is probably multiple enterprise servers and an ELB in front of them. So you'd use that as your URL and host name. And then finally, you specify where the database is, where the Postgres database is. The Enterprise web app can also send emails when you invite users. So if you want, you can have an SMTP server configured locally to send emails out. And then finally, you want to point it at where the meta servers will be. So we'll get those set up in a second. But I've already pre-filled that information here. OK, so now that we have it installed and we have our config set up, we need to basically run the migration to set up the database. So that's this command here. Influx Enterprise migrate, we point it at the config, and then we see this output. OK, so we've run the migrations, and we have everything set up in the database. And finally, we can just start the service. OK. Now we'll move on to setting up the meta servers. So I have 3 servers here. And we're going to use, for this demo setup, we're going to use the same servers for the data nodes and the meta nodes. You can either have them run on the same servers or on separate servers. So the key thing to know about the meta nodes and the data nodes and the setup is that you want to have ports 8091 and 8089 open between the meta servers so that they can talk to each other. So here's the command to install, which I already have it installed, so we don't need to run through that. Then after we've done that, we want to edit the config file, which is here. And we want to add the host name in, and then whatever our license key is. So once we've done that, we can do, we can start the service. We'll go ahead and we'll start it on every single one of the machines. So we see that it's started. And then on the first one that we started up, we're going to run the commands to have the meta nodes talk to each other and create a cluster. So that uses this command called InfluxDB CTO. All right. Now we're up and running. OK. We started the meta nodes. Now we'll go back and see if we can actually add them. OK, so that's what we'd expect. So that's node number 1, node number 2, and finally node number 3. Oh, there we go. OK, so if you look at InfluxDB CTO, you can see there are a bunch of commands that we have here. So here, let's just do a show. OK, so we see we have the meta nodes there. We have the 3 meta nodes. We don't have any data nodes yet. So that's what we'd expect. So let's get a couple of data nodes installed. So with the data nodes, you need to have port 8088 open between the data servers and the meta servers. And the data nodes need to be able to reach the meta servers on port 8091. And then finally, port 8086 is what you'd have open to the outside world or to your Elastic load balancer. So generally, in a real production setup, you'd have an ELB setup that balances between the data nodes, and you would send all writes and all queries to the ELB. So here we have the command to install the data node. And then we want to edit the config file. Actually, we want to enter in the host name and then the license key. And actually, the important thing to note about the host name is this is what the data nodes use to talk to each other. So when they announce that they're members of the cluster, they use this. So they need to be able to communicate on that interface to the ports that I mentioned previously. So once we have that entered in, we can start the service. So we do that here. OK, so we see that we have that running. Run through the install here. And then start the service. Okay, now we can add the data node. So do that here. And we use that 8088 port. Oh. InfluxD. Okay. So now if we do InfluxD-CTL show, there we see the data node that we just added. So let's go ahead and add the other one. Which is here. And then if we show it again, we see that we have the data node there. Okay. Now that we have those up and running, let's go ahead and start. And we have Enterprise started. We can take a look at the web UI in Enterprise. So that is going to be, I've changed the config on Enterprise to just be on the same port as the other one. So here we see the first screen for Enterprise. The first thing we have to do is we need to create a global administrator that has permissions to do everything within Enterprise. So we'll do that here. Oh. And you can create a database right here during the setup process. We'll skip this because I have a demo script that does this for me. So here's the basic screen. There's nothing really exciting going on yet because we don't have any load on the database. So let's kick off a test script. I'll take you through that really quick so that we can create some load. So this is a demo script that I wrote, and we can share out a link to a gist of this. It's written in Go, and it basically will write data to multiple data nodes and send queries to multiple data nodes. And it's just like fake data. So the first thing it'll do is it'll create the database. So here, we write historical data. So we create the database, and what we're going to do is we're going to write in a bunch of data in the past so that we can see multiple shards within the database. And I'll go into the shard stuff in a second. And then after we write the historical data, we loop through and we create clients for each database that each data node that we're going to be connecting to. And we just consistently write and query data. So these are basically just, endless loops that all they do is they just write some dummy data so that we can see, okay, there's some load being generated and data is going through and it's being replicated within the cluster. Okay, so I'm just going to run this from my laptop. So we're going over the internet. So here we have our two hosts specified, right? Comma separated. So we know we're going to be writing data to these two data nodes. So we created the demo database. Now we're going to write the historical data. So we just wrote, 180,000 data points. And now it's going through, and you can see for each host, okay, so we're posting some values, and we're doing it in random periods of time just to create, something that's a little bit more interesting for the user interface. And then we're doing queries as well. So here we can see, okay, yeah, we're seeing load that's starting to come in on the database. So we can see, we have a bunch of active queries that are running. We have a bunch of active writes. You can see the data nodes here, each one individually. This is for the cluster as a whole. And then the meta nodes, you can see their information here. So one screen that's pretty interesting is the queries page. So none of the queries we're running right now take very long to run. But what this page is it shows you what queries are running within the cluster. So if you have a query that's long running, that's misbehaving, you can actually kill it from this interface. And you can see how long it's been running for. As I said, these queries are all very, very fast right now. So there's not too much going on in this screen. So then if we look at the database, we can see some stats about the database here. This is the internal database. We can select up here which database we want to look at. The demo database is what I'm currently writing data into. So we can see, OK, not that much data in it so far. Like I said, it's just dummy data. So there's really only one measurement in one series. And you can also create a database from this screen. And then retention policies. So within a database, you have retention policies. And within retention policies, you have a bunch of shards. This is how we distribute data within the cluster. Shards are basically just contiguous blocks of time. So if we switch over to the demo database, we can see, OK, we've got these old historical shards. You can see the time range for it. And you can see, OK, the shard with this retention policy, replication factor of 2. So what that means is each one of these shards is copied on each one of these nodes, and you can see the sizes of these. You can also drop shards completely from the cluster from this interface. We did make it so that you actually have to confirm by typing delete if you want to do that, so that you don't accidentally click on the delete button and drop shards. And again, only the administrators have the ability to use this. You're able to lock down a bunch of these features and make it so that certain users can access certain functions. So that, I guess, brings us to the next piece, which is the access control, right? We can create users, and here we can invite a user using their name and email. And if you set up the SMTP settings, then they'll get an email with a link to access the app. And then you can also create roles. So you can assign permissions either to users or to roles specifically. If you look at the global admin, they have all of these permissions on all of the databases, right? So they can view this administrative screen. They can view chronograph. Oh, one sec. They can create databases. They can create users and roles. So here you can get a feel for all the different ways you can restrict access, right? So by default, if they don't have a right, then they won't have it. You have to grant it to them explicitly. So users can have multiple roles, and users can be assigned permissions directly, or permissions can be assigned to roles. All right. So let me just jump over to the Data Explorer really quick, and then we'll do some things like simulating some failures within the cluster. So we've looped chronograph into this interface. So this is going to be the one home where you can do administration, but you can also do things like explore your data and look around at it and export it. And we'll have export functions to export things as images or export them to Grafana dashboards. The idea behind the Data Explorer was we want to give people a easy view to just kind of dig around in their data and see what they have. So for this demo, we're going to look at the internal database. So Influx writes data to an internal database, which is just data about how the database is performing. Query response times, writes, how many writes are doing, how much disk space is being used, all those kinds of things. So because it's actually real data, it could be a bit more interesting than other things. So here we can see, query durations. And you see here, like, this query updates as we navigate around. So basically what we've done is, on the first screen, we selected a database and a retention policy, right? Then it has a select measurements. And if we have a lot of measurements, we can filter that in here, or we can just find the measurement we're interested in. So if we look at HPD, then once we've selected a measurement, it has a select fields. And we can select multiple fields, right? And we can apply multiple functions. So we can show like the mean, the min, the max, apply that, and set a group by time. And then finally, we can see tags. So here, we have two nodes in the data nodes in the cluster, so we can say, oh, let's group by this, so we see the two separate data nodes. And here you can see all the different things that are there. The other thing you can do is you can actually add multiple graphs to this screen, right? So if we wanted to have two things, one over the other, we can say, okay, let's look at that, and then let's look at write requests, and here we'll do a mean, apply that, and do a 10-second window as well, and then we'll group by the host name on this one too. They're pretty consistent. And then here at the top, you can select the window of time that you're looking at, and that'll change for all the graphs that you have on the screen. And if you've got a bigger screen, you can potentially get more than just two graphs on a page. You can get multiple panels. And then the last thing about the Data Explorer is this whole time while I've been navigating around, it's been saving this state. It's been saving the state to the backend database within Enterprise, so that if I go somewhere else, right, back here, and then I come back to the Data Explorer, I get all the same state that I had before, but importantly, I can save this, I can edit it and say, oh, this is my session where I was looking at HTTP requests. Rename that, and then here we can create a new session, go through, explore our data, take a look at things, number of series. That's going to be pretty boring right now. And then we can jump back to previous sessions. And then finally, if we want, we can delete a session. So that is the basics of the Data Explorer. Okay. Now that we've got that, we'll go back to the overview page, or actually back to the retention policies page, so we can do the next part of the demo. So here we can see we're writing data. Obviously, shard 7 is the shard that's basically hot for writes right now because we're writing in current data. So let's jump back over here. Let's go ahead and stop the InfluxDB service. So we've had a failure in the cluster. Okay, so that's stopped. What we'd expect is, okay, we're getting errors back from one of the hosts, from the host that we just brought down, right? And that's the web app is currently pointed at that host. So now what we want to do is bring it back up. What we'd expect is that everything is back up and running. So as you can see, the amount of data stored on each data node is different right now. So what's happening behind the scenes is a system called hinted handoff queued the writes to for the other server to disk. And based on a timeout, it will pick up in a number of seconds and replicate those writes over that it missed while it was down. So that is this setting here in the config file. If you go down in the config file, you can see the hinted handoff section right here. And we have things like where the data gets written to, the max size on disk that it can take up, the maximum age. So depending on what your throughput is, you want to have like a large amount of disk so that you can queue up a lot of old writes, or maybe you don't want to have a huge amount of disk. So then there's the retry settings. In this case, we have the retry max interval set to 1 minute. So it backs off exponentially so that if the server's down for a little while, it could take up to 1 minute to start syncing back up again. And you can lower this to something much smaller so that it recovers much more quickly. So there we see the sizes of the shard on the two servers is back up so that it's equal. So we can see that the hinted handoff kicked in and it replicated the data that it missed while it was down. Okay. Now, the last thing we want to do is we want to add a server to the cluster. Okay, so kill that. All right. So so we're going to install the data node on this third server. And I've already pre-configured it with the information in the config file. Start the service. See that it's running. We'll go back here. We'll add this new data node in. So we expect to see it there. We see it's there. So now what we want to do is, in this case, say we added the new data node in because we want to triply replicate our data. And we'd want to triply replicate it over doubly replicating it for two reasons. One, it's just more safety in terms of failures that you can tolerate. And the other is, the more you replicate your data, the more query scalability you get, right? You can do more queries on the same data set because it can be farmed out to different servers. So in order to do that, we're going to alter the retention policy. So here we see, okay, here's our retention policy, the default policy that we created, replication factor of 2, right? So now what we want to do is we want to alter the retention policy and up it to 3, right? So we have alter retention policy, the policy name on the database name, and same settings as before for duration. Now for replication, we set 3. And so duration and shard duration are the same as before. All right. Now if we show it here, okay, we see it's updated to 3. So next thing we want to do is, if you look here in the interface, this shard right here, this is the one that's hot for writes. Now, what happens with retention policies and replication factor is when we change the replication factor, it doesn't change it for historical data, right? We can change it manually for historical data if we want to by copying shards around, which I'll show in a second. But what it does is it changes it for the next set of shards that get created. So here we see that this shard is valid for a while longer. So what we're going to do is we're going to tell the server to close out that shard and create a new set of shards that are actually triply replicated. So, and that we can do using this command, InfluxCTL truncate shards. I should note that the InfluxCTL command, so it's a command line tool, but all of the things it's doing through an API. So later, we'll be releasing a client library for the API written in Go, and we'll also be releasing documentation around that API. It's just an HTTP API that can be called to do all of these functions. So we call truncate shards. And then let's start up our demo script again. Oh, actually, update the demo script so that we do not write the historical data. Let's take that out. see where we're writing data. So we're just writing to those two servers, but because we have a replication factor of 3, we expect new shards to get created. Let's see. Hold on a second. And here we see that we don't have stats yet for this one because we haven't been writing in data to it directly. It's getting writes indirectly through the other servers. All right. So here we have to wait for the internal database to update with the stats while we're writing in data. So let's give that a second. And actually, while we're waiting for that, there's another operation I can show you, which is, well, here I can show the shards, so we can see the different shards. So here, we can see the owners. So these are the new shards that are getting created, and they're updated with, now we have, triply replicated data for this new data that's coming through. So the other thing we can do is we can copy a shard from one server to another. So here, we're going to copy from the server we're on, source, here. We're going to copy to the new server we just added. So let's just copy shard number 6. And then if we do show shards, you can see that it's copied it over. Now, that was really, really fast because shard 6 doesn't have that much data. In a real system with, say, gigabytes of data within a single shard, you'd expect it to take some time. So what that copy shard function does is it makes a request to the cluster and tells it to do that, and then returns immediately. And then there's a command to show the status of shards that are being copied. Right? We don't have anything here because that shard's very, very small. But that makes it so that you can see what's happening with the shard that's being copied. And you can also kill shard copies that are currently running. Right? So if you want to abort an in-process one. So jumping back over here, we see that we have 3 nodes getting data. The sizes aren't interesting because the demo script is using fake dummy data. So that's everything I have to show for today.